This is my Wi-Fi router. But what is that device glowing green just beside it? Well, you guessed it right. It's a router UPS. It's completely homemade. Let me turn off the source power. As you see, the green LED goes off slowly. And it is completely off now. That means there is no source power. But still, my router is on. Obviously, power cut can happen at any time, and most possibly when you are in an important meeting, that happens. And let me turn on my source power now, and we'll take a closer look to my homemade device. And after that, we'll discuss about the components and the circuit diagram and other parts. Now let's understand what are the components required for our project. And here is my 18650 2200 mAh 3.7 volt lithium battery. And I have used 3 of these. And I didn't use the soldering part. I directly used this particular casing where we can insert and we can use the power using these wires. So we need 3 of these, and I am using 3S BMS or battery management system. I do not have a spare BMS, I cannot show it here, but we'll discuss that in the diagram. And here is one important part, which is step up boost converter. I'm using MT3608 model. Here you see V in plus and minus, and same V out plus and minus. What it does, if you put a lower voltage, maybe 10 volt, 11 volt, and it can give you your desired output. So for my router, I need 12 volt 2 ampere. This particular module supports up to 2 ampere current, and here is the potentiometer. By turning this counterclockwise, you can increase the voltage, and if you make it clockwise or turn it clockwise, the voltage will be reduced. So we need to use a multimeter and fix the voltage of the output to 12 volt. So precisely I have set it at 12.3 volt. So this is one key component, because when you are discharging your lithium battery, it can go down to 3.5 volt. So it will be around 10 point something volt. And we need to increase that at 12 volt. Along with that, we need another key component, which is a Schottky diode. And I am using 1N5822 model, which can handle up to 3 ampere of current. And the reverse voltage is, I think, 48 volt or something. What it does, it gives you only one way current, not the other way. And the switching speed is really fast. So that is why we are using this particular Schottky diode. Along with that, we'll need a couple of DC barrel jack for input and output power. And now let's understand how we need to design our circuit and how we can connect that. And as we have discussed, our main components were the BMS or the battery management system. Here is my DC to DC boost converter, and here are 3 lithium ion batteries. Here is our DC output and here is our DC input. Now let's understand how it is working. From the DC input, and it's 12 volt, we are taking the positive and sending that via the Schottky diode. And obviously the reverse will be stopped. And this particular, maybe let's call D1. It is going to the BMS input, which is plus. And we are also taking another line, and let's call it D2, and it's going directly to the output pin. Why is that? Whenever I am plugged into a DC port or the source power input is ready, it can directly send the power to my output. And from the D1, I am charging the batteries, and this particular BMS will be charging all 3 lithium batteries which are connected in series. And typical voltage will be around, for example, when it is charged, it will be maximum 4.2 volt, and the minimum discharge will be, I think, 3.5 volt. And BMS will manage the auto cut off and everything. Now, let's understand from BMS how we are taking the output. For example, this particular source line is dead now. That means power cut has happened. Now, this BMS will take power from this battery and it will send via this Schottky diode. Let's call it D3. Now this power will go into our boost converter. For example, maybe at that point the charge was maybe 4 volt. So it will be around 12 volt in total, which will reduce as long as we use it without the source power. Now this boost converter will make sure it is outputting to our desired voltage using this particular potentiometer. Now we are taking this particular power and obviously the ground is going to the V in minus, and from here we have put a DC switch. You can directly connect it, there is no harm, but DC switch will prevent whenever we do not want the battery to be activated, we can turn this off. Now from the BMS plus we are boosting it to our desired level and we are giving output to our DC output. Now how the auto switching is happening? The circuit is really simple as you see. For example, whenever my source power is ready, for example it is 12.6 volt and it is sent via this Schottky diode D2, then it is going to directly to my output and it may try to reverse from this V in, but it will be blocked via this particular D3 diode because reverse is not allowed in diode obviously. Similarly, whenever my source power is not there and if battery is present, the current will flow via D3 and via this boost converter and this DC output, it will try to flow back to my source or the DC input. But here is my D2 Schottky diode which will prevent the reverse current. And same here is also for safety. I have the D1. Whenever the battery is charged fully and if it is trying to discharge, this particular D1 will prevent anything to the input power. So here are our Schottky diode, and which is really fast. Whenever your source input is there, this will act very quickly, and whenever this particular input fails or your electricity is gone, this particular D3 will quickly kick off and there will be no delay in switching. And optionally we can have one LED to check whether the input power is present or not. So this is our working principle, very simple, very easy to understand. And to be very honest, I am not an electronics expert, I am an IT guy, but I tried to create it for my benefit. Thanks for staying till the end and let's catch up in some next amazing topics. Stay tuned.